Hello students, welcome back to my channel. So today we are going to start with the chapter 12, which is data file handling. So once we complete this lesson, we will be able to learn these many things from this chapter. So let us go through one by one. So objectives of this chapter is first to understand the concept of files. Now we have seen how to give an input for a program in C++ in the previous classes. Now today we are going to learn if at all we are going to give file as an input, and if we are writing the output onto the file, how we are going to do that. Okay. So before going to getting into that, we will understand what is the concept of files, how to usage we can use the files, the role of text and binary files. Okay, so what are the different kinds of files? Concept of opening and closing a file. So when I say that I want to give a input from the file and I want to write the output onto the file, of course we should also know how to open a file and also close a file. So that is what we are going to learn. Concept of input and output operations in text files, concept of input and output operations on binary files, and concept of file pointers and their manipulations. Okay, so these are the things which we will be learning in the further coming sessions. So let us begin with the very first topic. So the first thing what we are going to learn is some definitions. Okay, so what exactly is file handling or why it is required. Okay, so the very first thing is we should know that in C++, input and output operations are very much similar to the console. That is, if at all you have a program, okay, you have written a program and you have to give some input, isn't it? You from the console you always give an input, and we will always get an output on our monitor. That is again once again a console. Here the console will be your keyboard, like that. So using the console, how we give input output, we can also use files in order to give the input and also write the output. The file operations also make use of stream, such as interface between the program and files. Okay, so if at all I have a file. This is any file or any kind of a file which I'm using as to give. I want to extract the data which is available in this file, and I want to give that as an input to my program. I have written certain programs, and again the output whatever I'm writing, I want to write it into another file. In such case, I need certain type of interface or some files which will help me. For example, if I have to say we use header files, isn't it? We use header files in order to add our in C, if you're adding printf, scanf in C++, if you're using C out, C in, if you do not add your header files for input and output, you're not going to get a that particular command, that is your C out and C in, is not going to work. Similarly, we need certain stream handling files or header files, right? So today we are going to learn all that. Okay, now when I'm talking about a stream, what is a stream? Now when I say, usually when we say stream, it is nothing but a river flowing or a water flowing, isn't it? So when it comes to file handling, here I'm talking about stream is data stream. That is, I have an input stream and then I have an output stream of data which is flowing into the program as well as which is coming out of the program. So when I talk about stream, that is nothing but it is the data stream I am talking about. Data flowing into the program as well as data is flowing outside the program. Okay, so a stream is general name given to a flow of data at the lowest level. Data is just a binary data without any notion of data type. So when I say these file data are converted into binary, isn't it? Usually in the machine, how do we store the data? It is stored in the form of binary. So that data, when it is flowing, we will call it as a data stream. So different streams are used to represent different kinds of data flow, such as whether the data is flowing into the memory or out of the memory. That is very important. So whether the data stream is flowing into the memory or out of the memory. So now let us see the definition. So now this is important. If a byte flow from the device like a keyboard, this is what I said, okay, if we are giving input from a console, so a byte flow from the device like keyboard or a disk drive or a network connection, etc., to the main memory, it is called as a operation. Okay, so what is an input operation in general? I am giving input through my console. Now here they are saying it can be keyboard, that is you are giving the input, disk drive, that is from your secondary memory, and networking connection, okay, from somewhere from the network you are receiving a input. That is all will come and get into our main memory. Okay, that is main memory in order to process the data. Then that is called as input operation. Now, if a byte flows from the main memory to device like a display screen, that is nothing but your monitor, a printer, a disk drive, or a network connection, etc., it is called as output operation. Just the opposite. That is from your memory, you are giving output into any other device. It is called as output operations. Okay, so this is about input operations and output operations definition. Now, what is the information? The information The information or data stored under a specific name on a storage device is called as file. So now uh, we are talking about streams. Data is flowing from in a stream from a file. Now what is this file exactly? The information or data stored under a specific name. Okay, for example, in your system itself you can see you would have opened a Word file or an Excel file or any PPT, or which is saved under certain name, isn't it? It has to be saved in a certain name, so that is nothing but a file. So a file is nothing but information or data stored under a specific name on a storage device. Similarly, what is a stream? Stream refers to a sequence of bytes. Now see, small definitions you should be aware of, right? So see here we have a picture of a how exactly the data flows within a system. So we have here disk file. This is nothing but your secondary memory. Now about the secondary memory, primary memory, and everything we have studied in a very first chapter. Okay, so this is my program. Program is current something which is in execution, instruction which is currently in execution, isn't it? So this is my program. So this is my secondary memory. So I have input stream here, I have output stream here. Now we have seen. Now what is this input stream and output stream? The stream that supplies data to the program is called as input stream. Okay, the stream which supplies data to the program is called as input stream. Similarly, the stream that receives data from the program is called as output stream. Okay, so this is data from the program and this is data to the program. Remember this definition as well. So what is an input stream? An input stream that reads the data from the file and hands it over to the program. The stream that receives the data from the program is known as output stream. So see here exactly what is happening. I have a secondary memory here. I have a program here. Now, if a program is executing, obviously, if at all we are fetching the data from the file, I need to read the data from the file. So what is happening here? File to memory data is flowing in this direction. Once the program completes its execution, the output needs to be stored in the disk file. So that is when the data is flowing from in our output stream. So that is why we will say memory to file. So this is going in this direction. So that's all this diagram means. So here we are writing the data to the file, the whatever output we got from the program, and here we are reading the data from the file, that is for execution. So always it goes in this direction. Initially the flow comes here, gets executed, and then it will move to the secondary memory in this direction. Okay, I hope this is clear, students. So this is how a stream, input stream and output stream works. Next, let us see what are the header files which are required to be used in order to have our file, that is to read the file and to output the data onto the file. Which are the different header files which we require to use when it comes to C++? So you can see this diagram here. It is explained clearly that we have something called as iOS. Okay, then we have IS stream, I have OS stream, And then these are the few header files or the some files which we require. Okay, they which are some important files. I'm just marking it out here. So see this. Again, we are going to go and see in detail about each one of them. How does it work? What is the syntax and examples also I'm going to explain. So before that, understand the fstream base is derived from the basic class iOS. Okay, so here the arrow mark, this indicates that this particular file is being derived from this. Okay, that is your, this is your base class and this is your derived class. Similarly, the class isStream is derived from both isStream and fstream. Okay, so what is the meaning of that? Ifstream, that this particular one is derived from, let me use a different color. This one is derived from this as well as this. Okay, similarly, offstream is derived from OS stream as well as fstream. So if you see the, you might get confused with these different names which look similar, but just see the prefix here. When I say is stream, it is nothing but it is about input. Okay, similarly when I see I, so which means all these are dealing with the input. Fine. Similarly when I say OS stream, this is again dealing with the output. Okay, and when I say file buff, this is nothing but which we will be using for the buffer in order to buffer the file data when we are reading or writing onto the data, onto the file or out of the file, right? So the class of stream is derived from both OS stream as well as fstream. Now both ifstream and offstream act as a base class for the fstream class. And also, like I said, the file buff is derived from the class stream buff. As you can see, this one is derived from the class stream buff. So this becomes the base class for my file buff class. The complete class hierarchy is shown here. So central to file handling are three classes. They are ifstream, offstream, and fstream. So this you need to remember. Central, the very main classes what we will be dealing is ifstream, fstream, and OF stream. So basically we will be learning more about these three classes, but this particular picture is to show you how, from where we have derived which one. Okay, since we have learnt inheritance, you should know that which is the base class of this, which is the derived class of this. Now we know that we always, sometimes we, if at all you are including fstream dot h, okay, if at all you want to include fstream dot h, now in order to do the file handling we will be adding these header files. Okay, so fstream dot h file, if you want to add for file handling program, you need not include the iostream.h file. Okay, iostream.h file is not required because we know that this one is derived anyways from this and it will have a feature of iostream.h. So you can just include the fstream.h, that is more than sufficient. So all these qualities of an inherited program, that is base class, derived class, we have already learned in the previous sessions. Okay, so that is why this, understanding this or looking at this hierarchy was important for us to understand that which is derived from what. Now onwards we will be only looking mainly into if stream, off stream, and f stream classes, right? So let us move on and see what are the different actions or the operations available under these classes. Okay, so the very first one is file buff, which we saw. File buffer, like I said, it sets the file buffer to read and write. Now what do you understand by file buffer? Buffering is nothing but something which is loading before we um, perform certain actions. So we are loading and storing and keeping it in somewhere before we perform the program operation. So that is where your file buffer is going to come in handy. Fstream base. Now what is this Fstream base? It provides facility for file operations and consists of open close member functions. This is a base class for Fstream, ifstream, and offstream. Okay, remember Fstream base is nothing but a base class for these three classes. So it has both open and close operations available. Now what is this ifstream? Ifstream, like I said, remember the prefix. When it says I, it is nothing but input. So stream class to read from file. So when I say input, it is nothing but we are always going to read from the files. So it provides operations for files. It inherits function get, getLine, read, and functions supporting random access seek g tell g. Okay, now we are going to learn about each one of them in detail. So but as of now you understand if stream because it is about all about input. As you can see, the function supported by them is only which is related to input. So get is nothing but reading, get line is nothing but reading a line, read again is reading, seek g and tell g, these are all also the functions which will be using some pointers, okay, again to read. Next, about off stream. Again, see the prefix here, it is output. So well in advance we know that it is related to the output operations. So stream class to write on files, it provides output operations for files. It inherits the functions put, write, and function supporting random access seek p and tell p. Okay, so again these are the functions which are related to the output operations. That is why offstream classes support them. Remember, using if stream you can't output the data. Similarly, using the offstream you cannot read the data. They are exclusively for input and output operations only. Next comes is F stream. Now what is this F stream? It is a stream class to both read and write. Okay, remember, now F stream is something which is for both. It provides supports simultaneous input output operations. It inherits all the functions from the is stream and OS stream classes through the IO stream class defined inside the IO stream.h. Now we have seen this hierarchy in the previous image. So F-stream is someone which can do both input and output, right? So I hope this is clear. These are the main 5 classes which we will be looking into in this lesson, right? So next, let us see briefly about what are the different text files. In the next session, we will be discussing about the different operations or how we are going to read, how we are going to write on these files, right? So what are the different types of file we have? So we have two types of files, that is text file and binary file. So see here, depending on how the data is stored and retrieved, we have divided into two type of files. So what is a text file? A text file stores information in ASCII characters. We know that every character, that is your A, B, C, D and all those things, every character has a respective ASCII value. Now when it comes to text file, we are going to store that ASCII character of that particular file. For example, A has certain value, S has certain value, C has certain value, something like that. So whatever, if you want to store this entire content in a text file, what is going to happen is for each character their respective, for example A, F, I, L, E, for each character the respective ASCII value is what is going to get stored in the text file, right? So each line of text is terminated with the special character called as end of line. So for example, a file stores information in ASCII character. If this is the line, if you want to store, the respective ASCII characters are stored, and once the line ends, here we will have, in this text file we will have a special character known as end of line character or a delimiter character. This will indicate where the line is ending. So that is a speciality of the text file. Remember the two features, one thing is ASCII character and another thing is a end of the line character, which happens in text file. Next, let us see what is a binary file. A file that contains information in the same format as it held in the memory. So what is the meaning of this? Remember, in memory we'll always store all the data in the form of zeros and ones. So that is nothing but our binary. So likewise, we are storing it in memory, we will be storing it in the binary file also. So the content of the binary file is going to be zeros and ones. So and also another thing is no delimiters are used for a line or translation occurs here, which means I am not going to use any end of the line character. So what are the two difference we will see here? First thing is here I am using ASCII characters wherein which I am using zeros and ones here. Here I am using end of the line character wherein which I am not using the end of the line character. So the text files and binary files are entirely different from each other. Okay, so the next coming session we will be learning about the different operations which we can perform on this. So as of now, in this session only this much, students. Thank you for watching.